Welcome back, and in this video we're going to be looking at calculating the formula of compounds. So the first thing we need to do is understand what the different types of formulas are. So you're going to need your notes, a periodic table and a calculator. So before we do any calculations, we need to understand what the different types of formula mean. So an empirical formula is the smallest whole number ratio of atoms of each element in the compound. So for example, CH3. It tells me that I've got carbons and hydrogens in the ratio of 1 to 3. But it doesn't tell us actually how many atoms of each element are present. For that, I need the molecular formula. So you can see here my molecular formula, C2H6. Well, both of those numbers can be divided by 2 to get back to my empirical formula CH3. Lastly, the displayed formula gives me the structure of my molecule with lines representing the covalent bonds. So that would be the displayed formula of ethane. So if we know the empirical formula, we can work out the empirical formula mass. And if we're told the relative molecular mass, we can see how many times that empirical mass fits into the molecular mass. And then we can use this little formula here, that the molecular formula equals the empirical formula times x, where x must be a whole number, because the relative molecular mass must be a whole number ratio of the empirical formula mass. So for example, if my empirical formula is CH3, the empirical formula mass would be 15. Now if I know that the relative molar mass is 30, I can see that 15 fits into 30 twice, so x is 2. So the molecular formula is twice the empirical formula. In other words, it is C2H6. Again, if I take my empirical formula as CH2, the empirical formula mass would be 14. Now, if I'm told the relative molar mass, I know that 14 fits into that 3 times. So my molecular formula is 3 times my empirical formula. So I have C3H6. Now, if my molecular formula is P4O6, my empirical formula will be the smallest whole number ratio of that. Well, both of those numbers can be divided by 2, so I will get P2O3. That empirical formula mass is 110, and my molecular formula is twice my empirical formula, so my relative molar mass is 220 grams per mole. And I can do that for the rest of the table there. Do make sure you don't round during these calculations. It's always better with these calculations to keep the numbers for as long as possible in your calculator rather than rounding. If you round too early, you are going to get a strange number at the end. So we're on page 13 of your notes, and we're using these little tables to find the empirical formula. Now I'm told that I've got 5.8 grams of aluminium, and it's reacting with 22.9 grams of chlorine. So we've got the mass, we divide by the RAM, which will give us the number of moles in both cases. Now I want the ratio, the simplest whole number ratio of atoms, so I'm going to divide through by the smallest. And when I do that, I get a 1 to 3 ratio. And that tells me the formula is AlCl3. Now this is the empirical formula. We don't know whether it's the molecular formula because we've not been given the RMM. So in the second example, we have naphthalene. Now naphthalene is a hydrocarbon. A hydrocarbon is a substance which contains only carbon and hydrogen. And this time we've been given a percentage. So we said we've got 6.25% hydrogen. Well, if it only contains hydrogen and carbon, that must mean I've got 93.75% carbon. Now, as this is percentage by mass, I can say that 6.25% is the same as 6.25 grams. Again, I divide through by the RAM, and again divide through by the smallest, and I get a 1 to 1.25. Now, I can't round this number because I want the simplest whole number ratio. So I have to times this by a number to get a whole number. So in this case, I'm going to times it by 4, and therefore I have to times this by 4 to get the simplest whole number ratio. So this would be a 4 to 5 ratio. So the empirical formula is C5H4. The RMM of C5H4 is 64. But in this case, I'm told that the RMM, the relative molar mass of naphthalene, is 128. Well, 128 divided by 64 is 2. So therefore, the molecular formula is twice the empirical formula. So the molecular formula of naphthalene is C10H8. And I've just drawn naphthalene for you there. Sorry, that's supposed to be a straight line. So we've got the next example on the top of this page. So I've got 1.30 grams of zinc, 0.24 grams of carbon, and 0.96 grams of oxygen. I'm going to use my periodic table to find the RAM, and that's 65.4 for zinc, 12 carbon, 16 oxygen. Again, I'm going to divide these numbers to find the number of moles. So I've got 1.3 divided by 65.4, and that equals 0.0198. I'm probably going to keep more of that number in my calculator. I'm just writing down a few numbers for the moment. So we've got 0.24 divided by 12, and that is 0.02. And last but not least, we've got 0.96 divided by 16, and that is 0.06. Now if we divide through by the smallest, we get a 1.0, because that's the smallest number, to 1.006 to 3.018. Well, I can round these numbers a little bit, so I get a 1 to 1 to 3. So the empirical formula is ZnCO3. Now if I work out my empirical formula mass, I work out that it's the same as the relative molecular mass, so therefore the empirical formula equals the molecular formula. So empirical formula mass equals 125.4 grams per mole, which equals the RMM. Therefore the empirical formula and the molecular formula are the same. So very similar for this second example. This time I've got copper, iron and sulfur, and I get a 1 to 1 to 2 ratio. So therefore the empirical formula is CuFeS2. So we're continuing with page 15 of your notes, and we're looking at the formulas for examples 3 and 4. So again, very similar. Do make sure that your answer makes some sort of chemical sense. So Na2SO4 makes some sort of sense because we know that the formula of sodium sulfate is actually Na2SO4. So if I got a very strange number, I would go back and just check my calculations. It might be correct, but it's more likely that you've got a decimal place in the wrong place if you've got something like Na20SO4. So the last example on this page is one where we found the empirical formula is CH2O, and we find out that the relative molecular mass is 6 times the relative empirical formula mass, and therefore my formula, my molecular formula, is C6H12O6. In other words, I've made glucose. So that just finishes this short video looking at how we can calculate the empirical formula given some data from an experiment. In the next video, we're going to move on and look at waters of crystallization using the same method, and we're going to look at the practical of finding the waters of crystallization of copper sulfate.